Slides are visible?
Yes, sir. Visible, sir.
Yes, sir.
Yes. Yes, we are in the second part of Unit 3, and hope you attended your second CT well. And I requested you to solve exercise number 15. Any deviation from the given answer? Have you solved? And the d square y by dx square for x is equal to 0.96. What was the answer? Whether it is right or any deviation from the given answer?
Sir, I get different answer.
Just a minute. My volume is very low. Yes. Anshu?
Hello, sir.
Yes. Go ahead. You're audible. That is good
Hello.
system. And my exercise number 16 is visible.
Yes, sir. Visible.
Then for me.
Yes.
Yes, the population, which is the exercise number 16, is also very similar to that of the problem number 15, and which is an forward interpolation, backward interpolation. The population of the certain town is given, and from 1931 to 1971, it was detailed. Find the rate of the growth of the population in the year 1961. That was the given issue, and when we are concerned about the forward interpolation, the top results has to be taken, and while doing the backward interpolation, we need to be conscious over the bottom values. That is what here, and it is very similar to the earlier problem and backward difference formula, and this is what the procedures in order to find the results. We need to find the value of r. The r has to be applied with the coefficients. That coefficient has to be applied in the backward difference formula, and the y 1961 is equal to 2.6675, and you please do step-by-step calculations and let me know any difference in from the detailed results. Then we can disseminate the accurate answers to all the students. And this is also for your practice. That is exercise number 17. A rod is rotating in a plane. The following table gives the angle theta radians through which the rod has turned for various values of the time t seconds. When t is 0, there won't be any rotation. When 0.2, it was 0.12, and it continues till 1 second. And for 1 second, the theta is 3.2. Calculate the angular velocity and the angular acceleration of the rod when t is equal to 0.6. When t is equal to 0.6 seconds. Here the theta alone detailed here, but we need to concern about the angular acceleration, angular velocity, and this is what the angular acceleration and angular velocity as well angular acceleration. And see, this is what the first and second difference, difference. And I wanted to refresh the first and second difference formula. See, this is what the first and second difference formula for forward interpolation and forward difference formula and backward difference formula. And here the value, that is 0.6, is nearer to the end results, so it is suggested to consider the backward difference formula. Dash of x naught is equal to y naught plus 1 by 2 into second difference of y naught plus 1 by 3 into third difference of y naught, and it continues concerning the difference square and plus and so on. Yes, someone.
Sir, your voice is breaking little, sir.
Yes, I think there is an interruption within net. Yes. Dhanush, whether it is good, Dhanush?
Yes, sir.
Siddhartha, now it is good?
Yes, sir.
Yes, yes, yes. See, this is what the anyone updated your system with Windows 11?
Yes, sir.
It was very fine, right? Who did?
Yes, sir. Hello?
Yes, 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 yes.
Yes, sir. I updated with Windows 11, sir.
Yes, Sanjay Krishna. It is very fine, right?
Yes, sir. Yes, sir. It looking good,
Yes.
and
See, this
there
is
is no
what this
problem.
screen. This is what this. Yes, so far I don't be any problem. And usually we need to depend. This is what the screen. I think my screen is visible, right?
Yes, sir.
Yes. Usually the windows start usually kept at the left bottom corner, but now it made it into center. And there are many. It was the while updating, you will recognize this is what the first impression, that start button became at the center, and there are many. If time permits, I'll detail this, what all the advancement made when compared with the Windows 10. Now we'll converge first. The theta is, and we need to find the angular velocity and angular acceleration. And we need to depend the y dash and y double dash. And see here, the one thing with the given detail is we no need to do with the difference table and all. We since it was already that t for the required angular velocity and angular acceleration already detailed in the given table, so we can consider the detailed theta, and with that theta we can proceed. So this is what the results. Angular velocity is 3.966 radian per second, and the angular, no, sorry, that is what angular velocity, and the angular acceleration is 4.2 radian per second square. Yes, integration, and this is what the last part in unit 3. There are many heads are available, and numerical integration concerning our service. It is converged with the trapezoidal rule. Why we need to do with these numerical integration? How it is applicable to the Department of Production Engineering, and how it can be applied to the final. That we will detail a little later. At present, I disseminate the content concerning the numerical integration. We will see the mathematics. Once you are very familiar with these mathematics, then we will talk about the applications. The trapezoidal rule. This is what the trapezoidal rule: integral over x, y dx, x naught to x naught plus nh is equal to h by 2, y naught plus yn plus 2 into y1 plus y2 plus and so on, yn minus. This is what the trapezoidal rule, and we'll solve the problem with the given trapezoidal rule. The compute the value of the definite integral over 4 to 5.2 log base e x dx using trapezoidal rule. You please take your calculator and you please cope up with us since we have very limited time to complete the syllabus. See, the finding the interval. In order to find the interval, that is H, the H can be obtained from the given limits, given boundaries. See here, the x naught, the lower limit is x naught and the upper limit is x naught plus nh. So it has to be varied from x naught to x naught plus nh. So from this information, we can find the, that is what the interval 5.2 minus 4 6. Here the 6, that is n we are going to assume n as 6. I'll tell you on what basis the n can be assumed. Here assume n as 6, that is 6 parts. So the numerator and denominator as 1.6 and 6, 1.2 and 6. So the h value is equivalent to 0.2. And see, this is what we need to derive the table from 4 to 5.2. See, 4.2, 4.4 and 4.6. It continues till 5.2 and respective y naught, y, respective y. The y, that is in the given problem, the y has to be taken, and here the y is log base ex, that is ln x. So y is our ln x. While applying with these data, that is ln4 and ln4.2, you can get 1.386 and 1.4351, and it varies till 1.6487. And so this is what we need to apply with the trapezoidal. So the h is obviously 0.2 divided by 2, and y0 and y6. We have y0 as 1.3863 and y6x 1.6487 plus into we need to accumulate the y1 to y5. This is what y1, y2, the intermittent values. The intermittent values has to be accumulated, and it has to be multiplied with 2, and then it has to be added with the initial and final value, and it has to be multiplied with h, and it has to be divided with 2. And yes, someone you please unmute your mic and tell me the results. What is the answer for this particular problem? Whether it can be calculated without doing these trapezoidal rule, these mathematical solution, that is integral of simple formulas, can be done. Can either by calculator or anyone tried? Okay, we'll crack these things later. And now tell me the results. By doing this simple calculation, what is the answer for the integral over 4 to 5.2 log ln x dx? Siddharthan, for me. The first batch, you unmute your mic. The first batch of students. This is what 31st class. 30 into 5, 150. Yes, first batch. You please unmute your mic. Amin, Amolya, Anshu, Arvind Bosch, and Dakshish.
Say 18.2766.
18 point.
2766.
Sir, I think 1.8286.
Okay,
Somewhere you missed the
I
digit.
divided by.
Yes.
Yes, approximately 1.8 to 766.
Okay, fine. Anyway, whether this can be solved directly with the aid of calculator, you tried, Siddharthan, whether it is feasible?
No, sir, I don't have idea.
You don't have any idea. Okay, I'll tell you. For in order to get the results for this particular problem, I'll tell you. Let me convert this limit as 2 to 5. Okay. Yes. 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 Now check. Check the calculator. My calculator is visible. Amolya? Arvind Bosch?
Yes, sir.
My calculator is visible. Visible.
Yes, sir.
Yes. What we need to do here, we have the option called integral. See, integral, and then you apply the function. Apply the function within a bracket. Here we don't have many terms, so we have a single. So you apply without bracket. You apply your ln x, ln x. Apply here as ln x. Comma, put comma, and I have changed the limit. Before that, we will try with this particular problem 4. This is what the lower limit. Apply the lower limit and again comma and apply the upper limit 5.2 and again close the bracket. Okay, now give equal to. Now give equal to, it populates and it returns the value 1.857847, right? This is the way we can get the results even for the simple integral in the calculator by varying the lower and upper boundary. Convert the lower boundary as 2 and let the upper boundary as 5. The results, see, 3.6606 is Amolya.
Yes, sir.
Yes, Amolya, vary your lower boundary as 3 and upper boundary as 8 and tell me the results.
Sir, I'm sorry, sir. I couldn't see the screen properly.
Whose screen?
So
My
your,
screen.
yes, sir.
No, I'll tell you, take the calculator.
Okay, yes.
Arvind Bosch?
Yes, sir.
Is Arvind Bosch, continue once the Amolya problem is over, you tell me the result. I'll tell you the different boundary condition for you. Amolya, yes, you give integral dx. There is an option called integral dx under alpha.
Yes, sir.
Under alpha is you typed. Whether you typed, Amolya?
Yes, sir.
Yes. Now press ln.
Yes, sir.
Now alpha and dx.
So can you repeat?
Press alpha and press x.
Yes, sir.
Yes. Now press the simple comma.
Yes, sir.
Yes. Now you vary your is now give 3. That is your lower limit.
3.
3.
Okay, yes, sir.
Then comma 6. Close the bracket. Type 6 and then close the bracket. Give equal to.
So 4.4547.
Very good. Very good. Arvind Ghosh, vary your lower limit as 1 and upper limit as 7 and tell me the results. Arvind,
I'm calculating, sir.
and yes. 1 and 7.
So 7.6214.
Yes, 7.6214. Okay.
Sir, 7.6214, sir.
Very good. Very good. Okay. Again, my slides are visible.
Yes, sir.
Yes. In the similar fashion, you try the answer before getting before doing your calculation, and if it is your results are not concurrent with the calculated results, then somewhere we did mistake, and you try to resolve the mistakes and you try to get the accurate answers. And this is what exercise number 19. Evaluate integral over 0 to 1 e power minus x square dx by dividing the range of the integration into 4 equal parts using trapezoidal rule. Before getting the answer with the trapezoidal rule, Siddharthan, tell me the answer by using calculator. E minus x square.
So 0.7468.
Just a minute. 0, 1. 0.
7468.
Very good. 74682. That is what the results. Anyway, we'll try with the trapezoidal rule. And here the n is given in the problem. The n usually based on our interest, you take the n value and you proceed. And the length of the interval, that is h, is equal to upper boundary minus lower boundary divided by the number of parts. So here the h is equal to 0.25. Based on this h and lower and upper boundary, we can get the results of various e power minus x square, and this is what the various intervals and various results 1 and 0.9394 and 7788 until 0.3679. They have various based on your interval. This formula is also revised, that is trapezoidal rule. H by 2, the initial and final value, plus 2 into the intermittent terms, that is y1, y2 and y3. And by the application of various y values in the trapezoidal rule, you can get, see, yes, this is what the results 7430. The answer detailed by Siddharthan is 7468, and this might be the inaccuracy in the numerical, the results, the way in which we approach the problem might have some issue, and that is what the deviation, that is 7468 and 7430. And see, this is what the exercise number 3. Evaluate integral over 0 to 1 dx divided by 1 plus x square using trapezoidal rule with h is equal to, here the h is directly given, 0.2, hence determine the value of, through that it is advised you to find the value of pi. What is the relation between the trapezoidal rule and pi? Someone, you make a detailed note about this given problem, how it can be related with the pi value.
So integration of 1 by 1 plus x square is tan inverse of x.
Tan inverse of x is
So from like trigonometry, they are relating it to pi. That angle.
yes. What is the value of pi by 4? Pi divided by 4. What is pi by 4? And then we'll try to find the value of tan inverse of pi by 4. Yes, that is what the lead. Yes, we will crack one by one. See, integral over 0 to 1 dx divided by 1 plus x square is equal to this is what 78374, and the pi value we already have had. And you try to solve this particular problem, that is using this trapezoidal rule, and the idea for getting the pi value is also detailed. And any doubts, you please let me know. Any clarification with these trapezoidal rule?
No, sir.
Any clarification with these trapezoidal?
No, sir.
No. Okay, any
So I integrated and I found the answer same as pi by 4.
pi by 4. Okay. What is pi by 4? What is pi by 4? You tell me. What is tan inverse of pi by 4?
So pi by 4 is 0.78539.
Yes. Okay. Okay. Someone, you please unmute your mic and tell me about the current affairs. And already the time is 12:08.
So basically, last week or something, 4 Chennai lakes will now be notified as wetlands for helping in conservation. So lakes in Velachery, Madipakam, Ambattur, Korattur, along with Palikarnai, they are going to be notified as wetlands under the Wetland Conservation and Management Rules, which was formulated in 2017. So that is inside Chennai region, like that. That has been something off the topic. Also, like
Okay.
on one
What
day,
was
like
this?
with further identity.
Any benefits or any drawbacks for the people who lived in that area?
That part I'm not sure, sir.
Mm-mm.
At least in the Palikarnai marshland, I don't think anyone lives over there. I've seen that region. Yeah. In like that region actually requires protection in the sense like more than a wetland, it looks like a dumping ground. In like if you are traveling along that particular road or something, you cannot let your vehicle's windshield down because the normal air over there it seeps a lot. So it is necessary, I feel, to conserve lakes and also for the fact that Chennai being one of the wettest cities, even when compared to London, Chennai receives more rainfall annually. But still Chennai faces water issues. So I mean, they have to take care of their water resources. So, I mean, right. it was a good move.
Oh, fine.
That was one thing. And another thing, Chief Minister M.K. Stalin on Saturday or Friday, I'm not sure, last week. He basically hopped onto, like he went inside a bus suddenly as a surprise entry, and like he inquired about like how is the bus travel and the conditions which is of the bus travel with the passengers. He asked them for a feedback, especially from the women passengers for whom free entry to inside the MTC buses is allowed. So that was another news.
Yes, there are many things. There are many headlines are there to discuss about. Either it might be Uttarakhand or Kerala. That the huge rain or regarding Mullai Periyar, and there are many issues. Even the World T20, and anyway, we'll discuss in the tomorrow's class. We'll talk about the other things.
Okay.
Is regarding this that China again wanted to enforce the area, and India also trying to have the powers with the region in the Arunachal Pradesh, and now China created a peculiar or a special law regarding the saving of these laws between the areas between Indo and China, that border, and there are many, and we will anyway will talk one by one. Yes. Yes, my slides are visible. Yes, this is what the we were completed unit 2, unit 3, and unit 4. The first half is already over, and now we will crack the things in the second half. That is unit 4, second half. And with this second half, the my portions are over. I have already given unit 1 as assignment from the November 1st. You are going to give your heads which is in the unit 1, and now we will detail about the Euler's and Rangagota method, and find a difference method, minimization problem, least square approximation, and optimization. This is what the left out in numerical methods, and we will crack one by one. That is Rangagota method. And see, this is what 1934 the Rangagota introduced the method, and later it was Rengo introduced, and later it was improved by Rangagota. And increments of the functions are calculated for all by means of definite set of formula. And see, this is what the second order for finding the results of second order. This is what the given set of mathematical formula, that is if y is equal to we have certain functions called y, then dy by dx is equal to f of x comma y. The k1 and k2 as h into f of x naught comma y naught, and k2 is equal to h into f of x naught plus h by 2 comma y naught plus k1 by 2. Here k1 by 2, h naught by 2, and k1 by 2, and delta y is equal to k2. Here delta y is equal to k2. Through delta y we can find our y1. y1 is equal to y naught plus delta y. And this is the way that we are going to approach the Rangagota problems. And this is what third order, k1, k2, k3, and delta y. H is equal to f of x naught y naught, and our k2 is equal to h into f of x naught plus h by 2, the similar to that of the second order, y naught plus k1 by 2. Along with that, we have k3, h into f of x naught plus h comma y naught plus 2k2 minus k1, and delta y is equal to 1 by 6 into k1 plus 4k2 plus k3. And this is what fourth order. For fourth order, the rest of things are uniform. That is K1, K1, K2. K3 is very similar to that of K2. X0 plus h by 2 and y0 plus K2 by 2. Instead K1 we need to consider K2, and K4 is x0 plus h plus y0 plus k by 3. Delta y is equal to 1 by 6 into the K1 and K4 doesn't have any coefficient, but K2 and K3 has a coefficient of 2. And this is what the simultaneous differential equation. This will detail once the second order, third order, fourth order problems are over. At that time, we will come back and we'll see the simultaneous differential equation formulas. And this is what the problem number exercise number 1. And you please make a note. I think we don't have sufficient time to note down these problems. Anyway, I'll share the once the class is over. At that time, I will share this PPT. Through that PPT, you copy down these things and find the value of y of 1.1 using Rangagota method of the third order and the Rangagota method of fourth order. And we need to find the value of y of 1.1 using third and fourth order, or the given function is, that is dy by dx is equal to y square plus xy and the boundaries, that is y of 1 is equal to 1. That is when x is equal to 1, y is also 1. And for finding the value, we need to do the differentiation. That is y dash is given, that is y square plus yx, and that is what f of x comma y. When we are applying the given boundary as 1 1, based on the given boundary we need to find the value of h. The required y value is 1.1 and the given y as 1, so the difference is 0.1. This is what the third order Rangagota method. This is what very simple. That is, we are going to apply the various values in the respective place, and we are going to find the value of delta y. Through that, we can integrate with the required y in order to find the newer y value. And we will calculate one by one. That is K1, K2, K3, and then delta y, and then y. See K1, for now to find y of 1.1, K1 is equal to h into y square. See here, h into f of x0 plus y0. So instead of the raw data draw formula, we are going to apply with an suffix as 0 and 0. Y0 plus x0, y0 power 2 plus x0 into y0. We know the value of these initial boundaries 1 and 1. H is also known. So the value of K1 is calculated as 0.2. Similarly, f of K2. Similarly, we need to calculate the value of K2. K2 is equal to h into f of x0 plus h by 2, y0 plus K1 by 2. Instead x and y, we need to accumulate h by 2 along x0, K1 by 2 along the y0. So y0, the given function is y square. Instead y, you adjoin K1 by 2. Therefore, we are getting y0 plus K1 by 2 the whole square plus instead x comma y. For instead x, apply x0 plus h by 2 comma y0 plus K1 by 2. Here apply the values of the boundaries and try to find the results of K2. So I am applying the values 0.2 by 2 plus 1 plus 0.1 by 2 plus 1 plus 0.2 by 2. See, this is what the results of K2. K3, h into f of x0 plus h, comma y0 plus 2K2 minus K2. Apply the boundaries, you will get the value as 0.30208. Apply in the given formula, that is K1 1 by 6 into K1 plus 4K2 plus K3. You will get delta y as 0.24135. Therefore, the y1 is equal to 1.24135. Fourth order Rangagota method. This was the results of y1 is for third order, and now we will deem the things with the fourth order. This is what the formula k1 is equal to h into f of x naught, comma y naught, and so on. And k1 k2 are already calculated in the third order, and there won't be any difference. And we need to begin with k3. K3 is equal to h into f of x naught plus h by 2, comma y naught plus k2 by 2. So adjoin the respective h by 2 and k2 by 2. We will get 1.25048 plus 1.174116, and this is what k4. Someone you please try to calculate the value of k3. Here k4 is detailed. I think somewhere I have presented. If someone you please try to find the value of k3. Arvind, tell me the value. Calculate the value of k3. Arvind.
Yes, sir.
Pranav.
Yes, sir.
Yes, Arvind, you calculate the value of k3. Arvind.
So 0.242464.
Point
242464.
242464. Yes, this is what the results of delta y naught 0.24149. You accumulate with 1, you'll get y1 as 0.24149. In comparing with the third order and fourth order, there won't be any difference with 3 digits, but we have the difference in fourth and fifth digit. And any doubts here? Any doubts in finding these, solving this Rangagota third and fourth order?
No, sir.
You don't have. Yes, this is what exercise number 2. By applying the fourth order Rangagota method, find y of 0.2 from y dash is equal to x minus y minus x. Y of 0 is equal to 2 by taking h is equal to 0.1. Anyway, I'll share the screens. You try to find the results for this particular problem. Anyway, I'll share in a quicker way. I'll share the screens. That is y dash is equal to y minus x. The initial boundaries are 0 and 2, and we here concerning this particular problem, we are going to deal with fourth order ADO, since it was only it was asked in the question. So k1, k2, and the rest, and this is what various results, and 0 to 1 2.205172, 2 as 2.42139. I'll post this question in the WhatsApp. You try to solve this particular problem. Okay, any clarifications? Any queries?
So about the presentation.
Yes. Yeah.
So one member in our group can't attend the presentation in that
Okay.
particular date.
Okay.
So we have to prepone our presentation.
Yes. What was the name?
Sir, actually, I texted you regarding the same yesterday. Actually, I'll
Srishti.
yes, sir. This is Rishti here.
Yes. Present your content. Rest. You present your contents. Let leave the Srishti contents, and others you do your presentation. We will ask Srishti to present on the next day.
Okay, sir.
Leave this Srishti portion.
Okay, sir.
I think someone also requested. I think any other request for changing this date? Nagashri, I think Nagashri, you made any request or Sushma?
It's the same team, sir.
Same team. Siddharth, you belongs to which team?
Sir, actually, our presentation is on 9th, sir, 9th November.
Sushma, okay.
Yeah, sir. We are one group only, sir. One team. Srishti, me, Siddharth, and Nagashri, and Tarun, and Tushant. 6 members.
Okay. Okay. 9th. Okay. Then you present. It is feasible by you to present on 8th. 8th itself, Sushma.
So actually, we'll be going out of station from 7th to 14th that whole week. That's why I'm not sure of the network connectivity there.
Okay, you do your presentation on 3rd.
Okay, sir.
Your portion you concentrate on 3rd, and be conscious. We have only 50 minutes. With that 50 minutes, you all the assigned all 6 or 5 people has to present, and from one end, anyone you take the lead and accumulate the PPT and present from your end, and the respective slides can be shared, and that can be presented. Concerning these two people, Sri Risti and Sushma, I think Sri Risti has to be postponed and Sushma has to be preponed. Sushma,
Sir, no,
for
sir.
your
Exactly, we are one
No,
team,
sir.
sir. Srishti and me.
Same team.
We
Sri
are one
Risti
team,
and
sir.
Sushma
Yes, sir. We are
in the
one
same
team.
team.
Same team, sir.
I think two girls has the request. Sushma and
No, sir.
Sri
I
Risti,
didn't
you
request, sir.
Sir, we wanted pre-pond.
I'm okay with.
We wanted to perform early.
Yes, sir. We want to perform early. Like we want to prepone the date to third.
just a minute.
Uh,
Wait.
Sir, but on third, another team has to present.
Yeah,
Wait.
it would be
For the
like
entire team,
it
no, it
might
is not
be
feasible. It's not
number representations.
Wait, just a minute.
So November 1st, it would be the
Check.
introduction and then the computer architecture. Like we go on.
Yes.
Yes, sir. Like November 3rd, it would be number
Sri
representation.
Risti, Sri Risti belongs to which batch?
Error estimation, I guess. Sushma.
So the errors estimation, sir.
Is
On 9th November.
Kritika. Yes, the confusion. Kritika.
Girtika.
I think today he is absent. She is absent. No, converting the entire batch is it is very it won't be feasible. Sushma, you do as per your plan. We will think a little later. Anyway, as per the schedule, you go ahead and you try to cope up your presentation. Tomorrow, 11:30. Sorry, 12:30. We'll meet. Thank you, Anga.
Yes, sir. Thank you, sir.